Okay, we're back. Now, continuing on in chapter 4. The previous video, we looked at critical value approach to hypothesis testing. In this segment, we're going to look at the second alternative to that, which is called the p-value approach. With critical value, remember there's going to be an alpha. Who decides on alpha? Remember, the researcher determines alpha, whether it's 5%, 1%, 10%. Alpha is actually preset before we conduct the experiment. Okay? Now with p-value, p here in p-value, p stands for probability value. With probability value, we actually let the evidence speak for itself. So it's by far the most common approach of the two is p-value approach to hypothesis testing. With p-value, nobody gives you an alpha. You again let the data speak for itself, and I'll clarify what that means in a few minutes. So, what p-value does, notice I have here the definitions. It's a couple of different ways the p-value is. P-value, that's the second bullet here. P-value actually quantifies the strength of the evidence against a null, something that critical value couldn't do. Now, when we say quantifies, it means it puts it in terms of numbers. Using a number, it tells you how strong was the evidence against a null. If it was weak, obviously, we probably would not reject a null. So, the p-value also, that's our first bullet, is probability of getting sample values as extreme or even more extreme than the ones we got, assuming the null was true. So for example, if the null says the average rent is $1,500 and my sample shows the average rent was $1,900, okay, p-value tells me actually what is the probability, the actual probability of getting something that extreme. Okay, the other thing, and I think I have that coming later on, p-value is the actual observed probability of a type 1 error. The actual probability of type 1 error based on data. And that's what p-value is. Okay. Now alpha is what we call the stated significance level, but p-value is the observed based on actual data significance level. Now observed significance level, for short, that would be OSL. O for observed, S for significance, L for level. So some call it OSL. Now, using p-value criterion, how do we decide whether to reject or not reject a null? Well, if our p-value is less than or equal to alpha, we're going to reject a null. Okay. So, now here's a question. How do we actually find p-value? Now, your p-value, this is if you want to do it by hand. Minitab actually gives us the p-values once we determine whether we're doing a right, left, or two-tail test. It knows how to do it. But I'm just going to write this so our notes are complete. So, if the alternative is greater than, then the p-value is probability of a z greater than our test statistic. Okay, and I'm just going to put a subscript here, z naught. Now here z naught is actually our test statistic. Z naught is the value of our test statistic. And our test statistic, remember, is based on the actual data. So this is how it's found if you want to do it by hand, but don't worry about this. Now, as far as quantifying the strength of the evidence, this is what I meant by quantifying. If our p-value turns out to be more than 10%, the evidence is labeled as weak against the null. Between 5 and 10%, moderate. 1 and 5% strong. Less than 1%, very strong. So the smaller the p-value, the stronger the evidence becomes. So if p-value is, for example, 0.0001, that's 1 in 10,000. That's a good p-value to have. That means if the null is true, let's say my p-value is 0.001, 1/10,000. that 1/10,000 is the actual probability of a type 1 error. That means if I reject a null, I could have made a mistake. The probability of that mistake is 1 in 10,000, which is pretty good odds. Okay. Now, let's take a look at an example here with p-value. Again, don't worry about these. I'm just showing you how those formulas work. You don't have to do this. Minitab will do this for select problems. So for this one, in this example, I have let the value of test statistic for the right tail test of hypothesis be 2.14. So this is what we actually observed. Suppose alpha is 0.5. We want to decide whether to reject or not reject a null. So our p-value is probability of z greater than 2.14. You can get this probability at this point from Minitab. I use the table. And that probability is 0.162. And because our alpha was 0.5, this one is stated alpha is 0.5. 0.162 is less than that, so we reject the null. Whatever the null was, we're going to reject that null. Okay. And here's another example. This is for the two-tailed test. Let's say our test statistic for the two-tailed test turned out to be negative 2.14. Our alpha significance level, the size of our hypothesis test, is 0.25. And what that 0.25 again means is this. We are willing to assume a 25 in 1,000. That's 0.25. 25 in 1,000 chance of making a mistake and falsely rejecting a true null when we shouldn't have. Okay, so that's what we're willing to assume, that much risk. So it gives you the risk of rejecting the null in error. So our p-value is 2 times probability of z greater than absolute value of that. And again, from the table, I found this number to be 0.324. Remember, the alpha was 0.25. Now, 3% is bigger than 2%, right? Or 2.5%. Because it's larger, we do not reject this null. Okay. So, just wanted to mention the p-value approach to hypothesis test. And we are done with this video, and we're going to actually take a look at some examples next using Minitab.